Hey everybody, I want to start the first video of a two-part little series on vector, a little vector module that we're going to be coding. I've been doing a lot of multivariable calculus lately in that class. Making a little module like this has been kind of convenient for me. Like doing the cross product of two vectors, it's not like an insane deal, but it's nice that I can just put it in something. And if I ever wanted to know the formula, I programmed it. So, once you program something, you have a really good understanding of how it works, because you can't just tell the computer to do this. You got to, give it step-by-step instruction. Like, you have to fully understand what's going on to be able to program something. So, I thought we'd go over how to do it. Today, in this video, we're just going to flesh out a lot of the methods that are going to be in here. In fact, probably all the methods that are going to be in here. And then the next video is going to be a lot of the errors that come up. Like if you get the zero vector, a lot of things get funky. So we got to account for that. So let's just start it off real fast. So I have here the class vector, and I have its initialization function. And then I have the if name equals main, just for testing purposes while we're in here. So this thing is only going to take in one parameter so far. It's going to be coordinates, and I'll make a little variable equals core, and it's going to be an array of their coordinates. Okay. Now, just real fast, if I wanted to, here's a couple of functions that you may not know of that I'm just going to show you real fast. Okay, so the underscore EQ stands for like equivalence. So if I were to compare this to another vector, how should it test whether they're equal or not? Well, I can express that myself. Normally it'll default and take over and like look if they're the same object or whatever, but I can look for different, I can tell it to look for different patterns. So I can say return. So, oh yeah, and I'll take in a vector. So it'll call this function automatically when I compare it with another vector of this class. Okay, return self.core equals vec.core. So it's just going to pair their coordinates. If their coordinates are 100% equal, we're good. They're equal to each other. They're equal vectors. Okay. So this one, __str__ is just what happens if I try to print it. Like if I try to print our vector out, what's it going to do? Which, I mean, normally it wouldn't really know how to print out a class, right? So we're going to tell it what to do. So what I'm going to do is I'm going to print it out in vector notation, where you see like, in math you'll see like something like that, with the brackets to denote it's a vector. So I'm going to go like this. And I'm going to say for x in self.core, I'm just going to output plus equals str x plus a comma. So for every coordinate I have, I'm just going to pop it in, the string version of it, and a little comma. But if we do it that way, the final coordinate, we'll get something like this. We'll get 0, 4, 5, and another little comma. Okay, we won't get that guy. We'll get this, right? So I need to strip off that remaining comma. So I'll need to go output. Oh, whoops! I shouldn't put it there. Output. It's going to be outside the for loop. Is equal to output dot strip, and we're going to take away that final comma that's not supposed to be there. And then we're just going to, because that strip takes off the leading and ending symbol of whatever you put in there. So comma is going to take off a comma at the beginning, but we don't have a comma at the beginning. We have a bracket. This is like useful for if you're reading in files and you want to cleave off like new lines or spaces and such. Very useful. Output plus equals, boom. And then we'll return output. Okay, so that's what happens if we print it out. Let's actually just try this out real fast. Let's just go print, so we'll make a new vector, and we'll say vector1 is equal to vector. Let's just give it some simple coordinates. Just give it 3, 4. Let's go 1. Yeah, let's go 3, 4, because when we calculate the magnitude later, we know it's like a 3, 4, 5 triangle. It's going to be the magnitude of that is 5. Just 3 squared plus 4 squared square root, so 9 plus 16 square root. And then we'll print vector1, and then we'll make a second vector, vector2 is equal to and we'll make it the exact same vector, just test that out. we'll print vector 1 equals vector 2. Okay, let's try that out. I already have a vector module in here because I coded it up, so I'm just going to call this vector 2. And 3, 4, true. Okay, awesome. And then now let's just change one of these to make sure that that's going to work to false. Okay, so everything's working so far. Fantastic. Alright, so the next part, might as well start from the basics. Might as well calculate our magnitude. Okay, calc. You know, I might as well just call it magnitude. Okay, and I'll put in a self. And the reason I'm not going to make it a variable, you'll see later on when I make the functions, a lot of them will return vectors, like the normal vector and whatnot, because if I don't do that, if I make a parameter, if I go like self dot norm is equal to, you know, a new vector, and I put in the normal of it, like the normal vector of it. And if you don't know what a normal vector is, it's just the vector divided by its magnitude, so that now its overall magnitude is 1. So it just points in a direction, so that when you dot it with things, or when you try to shift vectors into that direction, you don't edit them at all. It's really convenient. I'm not going to go too much into the calculus principles because you can go learn a lot of that, and that would just make this video really long. So I'm just going to say just if you maybe need a little bit of a refresher. But so if I did this, well then you notice when I create a new vector for the normalized, it will come back in and it'll create its own normal vector. And when it creates its own normal vector, that normal vector will have to go through an initialization function and have to create its normal vector, and so on and so forth. So if we create all these, parameters that are vectors themselves, well, they'll get caught in an infinite loop where they themselves as vectors will try and create their vector members, and then their members will try to create their own members because they too are vectors. So instead of creating them straight up, we're going to make functions that we call that will return those vectors so that we don't get caught in one of those infinite loops. So I'll say just return, and I'm going to make a lot of these functions one line, just so it's real quick, simple, and dirty, and it'll be good practice for some of you that need help using, or don't have a lot of experience using the kind of the one-liner array things where you don't need to use for loops. So the magnitude is the square root of all the members. It's the square root of all the members individually squared and then summed. Okay. So what we're going to do is we're going to make an array of x squared for x in self.coordinates. So we're going to make an array of everybody in our coordinate squared. Okay. We will sum them, and then we will square root it. Pretty simple. Okay. And then we'll put in two more methods. Normalize. Okay, so we'll make the normal vector of them. Okay. And we'll say, okay, normalize, return a vector whose coordinates are x divided by, here we'll do something, magnitude. So a normal vector is where every component inside of the vector is divided by the magnitude. So we'll calculate the magnitude here. Magnitude. And since it's a function instead of a field, I need to put these parentheses there. Vector x divided by mag for x in self.core. So we make an array of all the coordinates x divided by the magnitude, which makes us our array of normal vector coordinates, and we're just going to make a new vector out of it and return it. So two-liner, not bad. We're doing well. And then we'll add in add, subtract, and test those. Add vec. Okay. And we'll say return x plus y. Well, we want to return in a vector of them added together, right? So we don't ever, actually adjust the coordinates in the vector itself, but we can get another copy back of it. So that way we can keep our original vectors, but make a new copy of what it would be like if they were added, right? Because when you do vector math and you do v plus w, you get a new vector, you know, say u or something. You don't actually change the original guys. I mean, you can if you want to, but so we'll make a new vector who is x plus y for xy in. So we're going to add the two guys we're going to add the individual pairs of coordinates. So you add vectors. So if I had a vector 3, 2 and 2, 3, let's do 4, 5. You add their x's, so 4 plus 3 is 7, and then you add their y's. 2 plus 5 is 7. Oh, well, I came out 7, 7. Didn't even mean for that. But we need to put the list together. Okay. So to do that, there's a function called zip that you put in two lists, so self.core and vec.core, and it'll jam them into one list, one second order list. So I'll show you an example of that. And so first off, if I normally just do zip, and I say 1, 2, 3, and then over here I go just 4, 5, 6, and I zip it, it'll just give me zip object at that. It'll just give me an object of the two things tied together. If I actually want to view it, I have to go zip 4, 5, 1, 2, 3. Yeah, and there we go. See, it combines 1 and 3, boom, 2 and 4, boom, and 3 and 5, boom. So this may have been different from what you're expecting. Maybe you thought I would put them together, you know, 1, 2, 3, 3, 4, 5. But it doesn't do it that way. This is really convenient, especially if you're doing like statistical analysis or you're comparing two things. In our case, vectors is really nice. So we're going to do it like this. We're going to go list out the zip of the self.core and vec.core and just add every guy in those pairs. And make a new array out of it, pump it into a vector, good to go. Okay, now we'll do subvec. Now subvec, I will return addvec. Alright, you gotta put in a parameter for the other vector, my bad. So we'll do addvec, and what we'll put in as the other vector is a vector whose coordinates are going to be the negative, because subtracting is the same as adding the negative, right? So I'm going to make a new vector that has the same coordinates as vec, just negative, right? So I'm going to make a vector, and its coordinates are x times -1 for every x in vec.core. Okay, so it'll make a whole list of all the negative coordinates that were in that vec parameter we put in, make a new vector out of it, and then add it. Okay? So we're building upon the other functions. So let's test this. Did I really get rid of vector 2 down here? Vector 2 is equal to vector. So let's do something easy. Let's do 1, 2. Okay? First off, let's print vector 1 dot magnitude, and then let's print vector 1 dot normalize. Okay, so this should be 5. Magnitude, if I can spell it right. Let me look. Yeah, so this should be 5, and then this should be 3 divided by 5, or 0.6, and 4 divided by 5, and 0.8. So let's run that. Okay, 0.6, 0.8, 3, 4, 5. Yeah, okay, it's looking great. You notice it returns as a float because we did, you know, the square root of something. The square root of something in Python always returns a float. That's not going to affect us, but who knows? Maybe for another program you're doing that could affect you. So you always got to remember what your data types are. So let's do print vector 1 dot add vec vector 2, and then let's print out vector1 dot add vector3. Whoop, that's still supposed to be subvec. I don't know how to do that. Okay, so this should come out with 3, 4, plus 1, 2, so it should be 4, 6. And this down here should return 2, 2. Oh, addVec is not defined. Self.addVec, there we go. So we didn't have the self, so it was looking for a function that was like defined out here somewhere, or some parameter. Well, it was looking mainly for something local, but there is no addVec itself. So we needed to put self to specify, hey, we're telling you about a method inside of this class, okay? And now it knows where to look. 4, 6, 2, 2. Okay, so that's working fantastic. I do like printing them out with the arrow brackets. Is it? I do like the look of that. Okay, so those are all working. And the final thing we'll add, I'll make this a 3-parter then. Scalar and scalar. Let's call it scal. So scalar multiple. Well, if you want to multiply a vector by a scalar, you just multiply every coordinate by it. So what I'm going to do is I'm going to return a vector with coordinates of x times scal for x in self.core. Okay, and so I will print vector1 dot scalar 2. So that should multiply everything by 2, giving us 6, 8. 6, 8. Perfect. Okay. So, this video went on a little longer than I thought it would because we still have to do dot product, cross product, angle between two vectors, and then vector, and we'll do all the vector projections, scalar projections, and stuff next time. Alright. Thanks for tuning in. I hope you liked where this is going. See you next time.